Hello everybody. Here's your lesson for section 1-1, Understanding Points, Lines, and Planes. My name is Missy McCarthy and I'm a math instructor at Oklahoma High School. Before we get going on the lecture for today, I just want to remind you that the PowerPoints are available for you to download and print off, and you can use those to take notes. And if ever I'm doing an example, I want you to pause the video, try the example on your own, and then watch the video to see if you got it correct. Just because you're watching a video doesn't mean you're going to watch it like you're watching an episode of 2.5 Men or something like that. You still have to be active in the learning process. So we're going to start talking about the word geometry and what does it mean. What is geometry? Well, if we break the word into two parts, the first part being this geo part, and the second part being the metry part, we have two different meanings here for these two parts of the word. The first part, the geo part, refers to the earth. If you think about geometry, geography, geology, all of those words have something to do with the earth. So the geo part refers to the earth. The metry part refers to this word measure. Like the metric system is a system of measuring. So when you put geometry together, what the term really means is to measure the earth. Now back in about 300 BC, I believe, there was a mathematician by the name of Euclid who wrote essentially what was the first mathematics textbook using logic and using definitions and terms and a system of thinking, a way of thinking about mathematics and a way of thinking about the world. In that textbook, the 13 textbooks were called Euclid's Elements, and what he did is he laid out this whole system for measuring the earth. He started with the smallest little thing you could measure possible, and then he built upon that to build what this system that we currently know as Euclidean geometry, or sometimes you may hear me refer to it as planar geometry. Spinning off of what Euclid did, there are other kinds of geometry. There's spherical geometry, and there's a few other kinds of geometry out there as well. But we're going to study, in most high schools, almost all high schools that I know study Euclidean geometry. So that's what we're going to take a look at. So first we're going to start with an undefined term. An undefined term is nothing more than a term that cannot be defined using other figures. It's almost similar to like the word the. It's really difficult to define the word the because it's one of the most basic, simple terms in our language. And so we're going to start by defining the most simple, basic term in geometry, and then we're going to build our entire system. We're going to be able to define parallelograms and rhombuses and rays and segments and all of those in terms of these smaller terms. So the three undefined terms that we're going to talk about are a point, a line, and a plane. Now that's not that they don't have definitions, they're just more difficult to define, but we're going to do our best to describe what they are so we can use them in future terms. So here's our definition of a point. A point names a location, it has no size, and it's represented by a dot. We also use a capital letter to name the point. So you can see here in the diagram, we have a point there. Now we can't possibly draw a point and have no size, so you got to think a little bit about the fact that this point just represents a location. And then we name it with a capital letter P. So if you can think about if you had like the three walls in your house would meet. So you've got, say, this wall here, and you've got another wall there, and then you've got your ceiling there. That corner, that would be a point where those three would intersect, and we could call that point capital K. Our next undefined term is a line, and it's just a straight path that has no thickness and that extends forever in both directions. So you can name a line in a couple different ways. You can name a line with a lowercase letter. Here they have a lowercase l. Or you can name a line with 2 points on the line, so XY or YX. You just need to name any of those 2 points. When you name a line, you have to put the little double arrow over it. So if I had a line with 2 points on it, let's say I had line with a point A on it and the point B on it, then I would name this by saying either line AB or line BA. I could also call it with a script letter, a script lowercase letter, and say that that's line K. And then lastly, we have a plane. A plane is a flat surface that has no thickness and extends forever. So if you can think about like the ceiling, that would be a plane if it extended in all directions forever. It's named by a capital script letter, so you can see the capital script letter R to name the plane, or you can name the plane by 3 points on the plane that are not all on the same line. So points A, B, and C are not on the same line, and they lie in this plane R. Okay, so what are collinear points? The word collinear is actually a compound word as well. Co means together, like co-workers work together. And linear means on a line. So collinear points would be points that are on a line together. So if I had line here A, B, C, I would say that points A, B, and C are collinear. Points A, B, and C are collinear. They are on a line together. The same thing with this word coplanar. Coplanar means on a plane or in a plane together. Or I'll change that to in a plane together. Okay, so if I had a plane, I'm going to draw like this parallelogram type figure to represent my flat surface that extends forever in all directions. It really doesn't have edges, but I can't really draw it without edges. And if I had a point here, X, Y, Z, these points are coplanar. X, Y, and Z are coplanar. So that's an example. These two definitions, collinear and coplanar, are examples of terms that we defined using our previously undefined terms. So we're starting to build our system of geometry already. All right, so let's look at this example. Now here's a time when you could definitely pause the video and try some of these on your own. Try to name a point, try to name 2 lines, and try to name a plane, and then answer the question, are points E and point C collinear? Why or why not? So you can pause it right now. I'm going to answer it right now. Okay, so name a point. You have a variety to choose from. You could say A, B, E, C, D. Those are all points that are located in this plane. So I'm going to choose point B. Okay, so I named a point. You name a point with a capital print letter. Name 2 lines. Well, when I name lines, I have to name those lines with my little symbol over it that says line, and I need 2 points on the line. So I can say line AB. So that would be this line here that extends forever in both directions. Or I can name line AC, but another way to name line AC would be with the script letter M. Okay? Let's see, number 3, name a plane. Well, I can name it in 2 ways. I can name plane Z with a capital, or I can name it using 3 non-collinear points. So I could say plane A, B, C. I cannot say plane ABE, and we'll talk about why I can't do that in class tomorrow. And then number 4, it says, are points E and C collinear? So E and C, are they on a line together? Well, the line isn't pictured. However, is it possible to draw a line that contains points E and C? Absolutely it is. So because it's possible to draw a line that contains points E and C, I would say that E and C are indeed collinear. And I just showed you why they're collinear, because they can lie on a line together. Okay, a few more definitions here. I'm just going to go through these relatively quickly, but take your time, read through them, make sure you understand what they are. We're going to define more terms now based on the terms that we previously defined, the point, line, and plane. So we're going to call something, define something called a segment, which is, or a line segment is another way to describe it, which is just a part of a line consisting of all of the points in between two endpoints. So segments don't extend forever. So you can see here, this is only part of a line going from point A, that's one of the endpoints, to point B, which is the second endpoint, and all of the points in between. When you name a segment, you put a little dash over top. You don't put the arrows, because if you put the arrows, then you're indicating that it's extending forever in one of the directions. An endpoint is just a capital letter at the start of a segment or array. We're going to identify what array is in a second. So a capital letter, either C or D, so endpoint C or endpoint D. They're at the end of the segment. Array is a part of the line, but it starts at one endpoint and extends forever in one direction. So if we look here, we name array by starting here and then extending with the arrow over and just in one direction only. The arrow always points to the right when you're naming array, and we would start with the end point of the array and name a letter in the direction that we want to extend forever. So for example, this is ray RS. We would write the name of that ray just like this, ray RS. R is the end point, extending forever in the direction of S. Now this ray here is also ray RS. It's going to the left, but R is the end point and it extends forever in the direction of S. It is not ray SR. Ray SR would start at the end point S and go in the direction of R. That would be ray SR. Okay? And then our last one is opposite rays. There are two rays that have the same end point. So ray EF and ray EG are what we call opposite rays. They have the same endpoint and they form a line. There's two pieces of criteria. So the same endpoint, ray EG, and then ray EF, those two are opposite rays because they meet at E, that's the endpoint that they share, and they go in opposite directions, forming a line. Okay? All right, we also have postulates or axioms in geometry, and a postulate is a statement that is accepted as true without proof. A postulate. A statement accepted as true without proof. So these are things that we just know, almost like common sense type things. One is that through any 2 points, there is exactly one line. If I have 2 points here, I can draw one and only one line. I can't draw a different line because lines are straight. I can't draw a different line that passes through those 2 points. The second postulate is through any three non-collinear points, there is exactly one plane. So no matter where you position the 3 points in the air, you can imagine that there is just one flat surface that contains all 3 of those points. And then the last one is if 2 points lie in a plane, then the line containing those points lies in the plane. So let's say if we were to name these points here, let's name this point A and this point B. And let's name our plane script capital K. So if point A and point B lie in plane K, then the line that passes through A and B also lies in plane K. So those are 3 postulates. Okay, we can also have intersecting elements. We can have lines and rays intersecting each other in geometry. And an intersection is the set of all of the points that the 2 or more figures have in common. So we're going to have 2 postulates now about intersections. For example, if I have a line here and then another line here, let's call this line AB and let's call this line CB, we can say that those 2 lines intersect. And the next 2 postulates are going to talk about how they intersect. So this postulate says if 2 lines are going to intersect, they are going to intersect in exactly 1 point. So if I draw that diagram that we just had on the previous page, we had our line here and our line here. This was, or they may have been switched around, but you get the idea. So line AB and line CD intersect at point B. So any 2 lines that intersect at exactly 1 point. And if two planes intersect, they intersect at exactly one line. So I'm going to try to draw an image of that here, of two planes intersecting. So let's see, that's one plane. Then the other one is going to be kind of above it. So you come down to here. And then it would go below there. That dotted line signifies that it's behind the other one. So we've got this two planes intersecting here. Now where do those two planes intersect? They intersect in exactly one line. This line would be the line where those two planes intersect, because remember, those planes are extending forever in both directions, in all directions. All right, so let's sketch a figure that shows each of the following. Let's sketch a line that intersects a plane but does not lie in the plane. What would that look like? Here is a time for you to pause and try it. Sketch a line that lies in the plane but does not, that intersects the plane but doesn't lie in it. So I use a parallelogram to represent my planes, and I want the line to touch it but not to lie in it. So my line is going to be like almost as if you were to pierce a piece of paper with a pencil and have it going through. So here's my line. It intersects the plane, but it doesn't lie in the plane. There are points on the line that are not in the plane. And now I'm going to draw two planes that intersect in one line. Now that's the picture I just drew. And so let's try to draw a slightly different one now. Two planes that intersect in one line. Let's see, I'm going to draw one plane going back like that. And then the other plane coming out like that. Take that down, down. That's behind, and they're going to intersect right here on this line. So I guess that could be solid because it's not behind. So there are two planes intersecting in one line. All right, I want you to try this one on your own. Sketch a figure that shows two lines intersect in one point in a plane, but only one of the lines lies in the plane. Only one of those lie in the plane. Okay, so you can pause it and try it. I would draw something like this. Got a plane, line in the plane, line outside of the plane, and those two lines intersect at only one point, and only one line is in the plane. All right, rewatch any parts of the video, pause or whatever to make sure you have a full understanding of all the terms that we discussed. Be sure to take good notes. You don't have to print out the PowerPoint, but it is suggested. And there will be no lecture in class, so this is the only time you'll get this material. If you have any questions, you can type them in the comment section or bring them with you to class. See you then.